Electronics Hints welcomes you to know hints on digital circuits. Winners always will planners. Thank you for watching this video. Please like, share and subscribe to this YouTube channel. Receive more electronic information. Kindly suggest your valuable feedback to improve the forthcoming videos. Thank you. Electronics Hints. Adder circuit. The adder circuit is used to add binary bits. It is a combination circuit. The figure shows the block diagram of the adder. The inputs of the adder circuit are 2 or 3 bits and the output are 2 bits. The 3 inputs are 2 bits to be added and the carry of the previous addition. The outputs are the sum and carry of the addition. The types of the adder are off adder, full adder, 4-bit adder, 8-bit adder, parallel adder, serial adder, BCD adder and etc. The adder circuit is used in the digital calculating devices. Subtractor. The subtractor circuit is used to subtract binary bits. It is a combination circuit. The figure shows the block diagram of the subtractor. The inputs of the subtractor circuit are 2 or 3 bits and the output are 2 bits. The 3 inputs are 2 bits to be subtracted and the borrow of the previous subtraction. The outputs are the difference and the borrow of the subtraction. The types of subtractor are off subtractor and full subtractor. Flip-flop. The figure shows the block diagram of the flip-flop. The flip-flop is the basic building blocks of the sequential circuits. It is a bistable multivibrator. It has one or more input and 2 outputs. The outputs are complement to each other. Flip-flop is a 1-bit memory cell. It can store 1 bit of information. The types of the flip-flop are SR flip-flop, clocked SR flip-flop, JK flip-flop, clocked JK flip-flop, JK master and slave flip-flop, D flip-flop and T flip-flop. Counter. The figure shows the simple circuit of the counter. The counter is a sequential circuit. It is used to count the clock pulses or to record the number of occurrences of some input. There are 2 types of the counter. They are asynchronous counter and synchronous counter. The asynchronous counter or ripple counter is simple in all ways. Each flip-flop in the counter is triggered by the previous flip-flop. So this counter is called the serial counter. Every flip-flop in synchronous counter is triggered by the clock pulse directly. This counter requires more hardware. The counter is further classified to up counter, down counter, up down counter, decade counter, mode counter, skip counter, BCD counter, Johnson counter, ring counter and etc. The relation between the numbers of the flip-flop and the numbers of count is given by m is equal to 2 power n, where m is equal to numbers of the count and n is equal to numbers of flip-flop. The counter is used in microprocessor, microcontroller, computer and etc. Register. The figure shows the block diagram of the register. The register is used to store data. The numbers of flip-flop are equal to the amount of bits of the data. The shift register, in which the data is shifted from one flip-flop to another flip-flop for storing and retrieving the information. The types of the shift register are serial input and serial output, serial input and parallel output, parallel input and parallel output, parallel input and serial output. The registers is used in microprocessor, microcontroller, computer and etc. Multiplexer. The figure shows the block diagram of the multiplexer. Multiplex means many to one. It is also called as a mux or a data selector. The multiplexer is a logical circuit. It has many inputs, one output and one or more control lines. One of the inputs is selected by control lines and the selected input is connected to the output. The relation between inputs m and control lines n is given by m is equal to 2 power n. The mux is used in the communication and digital circuits and etc. Demultiplexer. The figure shows the block diagram of the demultiplexer. Demultiplex means one to many. It is also called as a demux or a data distributor. It is a logical circuit. It has one input, many outputs and one or more control lines. One of the outputs is selected by control lines and the selected output is connected to the input. The relation between output m and control lines n is given by m is equal to 2 power n. The demux is used in the communication and digital circuits and etc. Decoder. The figure shows the block diagram of the decoder. A binary decoder is a combination logic circuit that converts binary information from the encoded inputs to a maximum of 2 power n unique outputs. They are used in a wide variety of applications including data demultiplexing, 7-segment displays and memory address decoding. Decoder is a digital device that converts coded information into another code or non-coded form. It is a multi-inputs and multi-outputs logic circuit. The number of outputs is greater than the number of inputs. Encoder. The figure shows the block diagram of the encoder. Encoder is a code converter. It converts the decimal data to other coded form. The encoder has more number of inputs and enable line and less number of outputs. It does not have data inputs and has only control inputs. The relation between input m and control lines n is given by m is equal to 2 power n. Comparator. The figure shows the block diagram of the comparator. A digital comparator is widely used in combinational system and is specially designed to compare the two binary numbers and gives outputs. There are two types of comparator. They are the identity comparator and the magnitude comparator. Comparators that have only one output terminal and produces the output either low or high are identity comparators. Comparators with 3 output terminals and checks for 3 conditions, that is, greater than or lesser than or equal. The comparator is used in the address recording circuit, control application circuits and etc. Parity generator. The parity generator is a combination circuit. It generates the parity bit in the generator. A parity bit is used for the purpose of detecting errors during transmission of binary information. It is an extra bit included with the binary word to make the number of ones either odd or even. Parity checker. It is a circuit that checks the parity in the receiver. It checks for possible errors in the transmission. The parity generator and the parity checker are constructed by XOR gates. Memory. The figure shows the block diagram of the memory. The memory is a component. It allows short-term data access. The memory has data lines, address lines and control lines like read, write and enable. The memory capacity is expressed by n and m, where n is length of the word and m is number of the location. The memory capacity is expressed in gigabyte and more. The memory is divided to random access memory and sequential memory. The data can be stored or retrieved from the memory in any order in the random access memory. The data can be stored or retrieved from the memory in serial order in the sequential memory. RAM is a volatile memory. The RAM is further divided to static memory and dynamic memory. The ROM is a non-volatile memory. The ROM is further divided to PROM, EPROM, EEPROM and flash ROM. The sequential memory is divided to shift registers and queues. The RAM is divided to SDRAM, DDR, SDRAM. Thanks to Google and books. Kindly view my next video. Kindly regret the mistakes in the video. Thank you for your visit to this channel.